Wyoming is home to more geysers than any other place in the world. About 3 million visitors a year come to see Old Faithful and the other natural wonders of Yellowstone. Wyoming is the 10th largest state in the United States, yet it has just one congressperson in the U.S. House of Representatives. That's 1 out of 435 members. Why? Because Wyoming has the smallest population of the 50 states, and the number of representatives a state sends to the House is based on its population. How do we know the population of Wyoming, or any state for that matter? Every 10 years, the federal government takes a census of the people living in the United States. A census is supposed to be a complete count of a population. When a census is taken, surveys are mailed to every known household in the United States. Most ask just a handful of questions. How many people live at an address, and what are their ages, genders, and races? From the answers, the government develops statistical summaries about the general makeup of the U.S. population.
I got markers, pencils, everything to give away Census 2000. This is your future, don't leave it blank.
But the government also wants more detailed information, including information about how many people are employed, how Americans spend their money, and how many children and adults attend school. So 1 in every 6 households is sent a detailed questionnaire. This is an example of sampling, selecting a portion of the population to determine information about the whole population. The statistics generated from the sample are interpreted as reflecting the entire U.S. population. Sampling is used in a wide range of professions. For instance, a market research firm might do a survey to learn what products people in a certain community buy. In politics, opinion polls are important tools for collecting data. And in manufacturing, the quality of a batch of goods produced is assessed by testing a sample. In each case, the reliability of the data depends on how good, that is, representative, the sample is, how well it represents the population being studied. Let's sample some examples of sampling. Her name is Elvira. She's originally from Mexico. Inspectors at Chicago's O'Hare Airport found her illegally packed inside a suitcase. To catch all contraband, each of the roughly 14 million bags that come through O'Hare each year would have to be checked. That would be too time-consuming and expensive. Instead, each piece of checked luggage gets a computer-generated baggage tag, is X-rayed, and is sent to the cavernous underground baggage sorting system. There, its computerized tag is scanned. Out of the approximately 40,000 pieces of checked luggage that pass through O'Hare in a day, suppose 400 are selected for inspection by hand. Those 400 bags are a sample of the total population. Suppose, too, that the sample was randomly chosen, that 1 out of every 100 bags was selected using a randomly assigned computer number. A random sample is one generated so that every member of a population has an equal chance of being selected. Data generated by studying a random sample can be applied to the entire population. Now suppose the baggage inspectors found that of the 400 bags in their sample, 6 bags contain banned items. That's equivalent to 1.5%. They might conclude that the same proportion of the 40,000 bags that come through O'Hare each day contain banned items. 1.5% of 40,000 is 600 bags. That would be a reasonable conclusion if the 400 bags chosen for inspection made up a representative sample of the total population of 40,000 bags. But in many cases, samples are not random. A sample that overrepresents or underrepresents part of the population is a biased sample. If the inspectors decided to check only heavy bags, such as those weighing more than 30 pounds, all lighter bags would have 0 chance of being pulled. Or if they check only bags with items that look suspicious on the X-ray, they might miss some banned items but catch more than if they'd done a totally random selection. Young Americans have more disposable income than ever before. Suppose a market research firm wants to find out how they spend it. And suppose it conducts a nationwide phone survey, randomly selecting numbers out of phone books. Employees interview 1,500 young people. Let's say the researchers find that the survey respondents between the ages of 15 and 24 spend an average of about $2,000 a year, mainly on clothing, food, entertainment, electronics, transportation, and personal care. The market researchers think their results are representative. That is, they think their statistics apply to all Americans aged 15 to 24. But they may be wrong. Why? The market research firm did not have a clearly representative sample. Phone books list only the numbers for landlines. The firm did not take into account three groups of people: those who have cell phones but no landline, those with landlines whose numbers are unlisted, and those with no phone at all. Taken together, those groups may represent 10% or more of the target population. The biased sample overrepresented the segment of the population with listed landlines and excluded everyone else. If the spending habits of those who are excluded are different from the habits of those included, the statistics calculated from the phone survey could give a false impression of the buying habits of Americans between 15 and 24. To be representative, their sample would have to reflect the makeup of their target population. They could stratify their sample. Stratifying means dividing the population into subgroups of people who share some characteristic, such as those with listed landline phones and those without. If you select a random sample from each subgroup, you have a stratified random sample. Using this technique, you can make sure that each meaningful segment of that population is fairly represented. In this case, since about 90% of Americans between the ages of 15 and 24 have listed landlines, 90% of the surveys would be administered to that segment of the population. Similarly, 9% of the surveys would go to those with cell phones only, and 1% to those with no phone at all. Within each subgroup, the survey would be distributed randomly. Using this method, the market research firm could improve the chance that their sample is both random and representative. Young people represent the most active group of cell phone users. Suppose a wireless company is considering how to market to this group. The firm is interested in the spending habits of people between the ages of 18 and 22. Suppose company representatives visit college campuses across the U.S. The reps ask 100 students with cell phones on each campus how much they spent in the last year on non-essential items, such as entertainment, clothes, and electronics. The percents for each $1,000 range are displayed on a frequency histogram. The histogram displays how many of the averaged samples fell into each category. The wireless company gets the impression that more than half of American college-age cell phone users spent over $4,000 annually on non-essential items. Notice that the survey included only students with cell phones. Because it did not consider students without cell phones and did not consider 18 to 24-year-olds not attending college, the samples were not representative of the entire population in the target age range. A sample that is not chosen in such a way that it is representative of a population is said to be biased. But we can redefine our target population as cell phone users in college. For a sample to be unbiased, it must be random, one generated so that every member of a population has an equal chance of being selected. In this case, the colleges visited by the wireless reps would have to be representative of all U.S. colleges, large universities, small liberal arts colleges, public institutions, as well as private. In addition, the methods of choosing interviewees on each campus would have to be reasonably random. If the company reps stationed themselves on the steps of the library, they may have talked only to the most studious members of the campus. But if they had staked out the student union throughout the day, they might have improved their chances of getting a random sample. After all, a representative sample of the student body might be more likely to go there than to go to the library on any given day. In this case, the wireless company is not interested in the spending habits of all Americans, just some of those between 18 and 22. That's its target market. However, within that target portion of the population, it is still important to use unbiased sampling techniques. Otherwise, the sample is less likely to be representative of the part of the population the company is interested in. Here, young cell phone users attending college.